process related to assembler, which we started discussing about. Okay, we already addressed few aspects of it in terms of say what representations would be used for data structures like symbol table, opcode table, error table, and so on. So we'll move further. Now I have picked this image from the book of David Solomon. So this definitely gives you brief idea about what kind of code you are expected to write. So your program would be something like this. OK, this main program. And there would be different aspects used inside. So these would be the data structures that you have. So you have opcode table. So they suggested to make use of directive table. So it is your choice whether you want to provide the directive tables or not, or table or not, but definitely would be requiring symbol table. Now few things are missing here, like for example error table and so on. So we'll talk about it after a while. Though few things are shown here, I may not address those parts ultimately. So what exactly you are supposed to do? You are exactly supposed to take an input, a source file, which would be an assembly code, and you are going to read that file line by line. OK, now when it is scanned line by line, now what exactly we mean by it? So recall, if you recall, I gave you an assignment in respect of can you filter out comments from the source code? OK, and create two different files. One would be source code file, other one would be uh, the code which is not with the source file, correct, or source code. Fine. Now let me take an example. So say for example, let us take a code. So let us assume that we are using or we have written this NASM and we are working with it. So like while we work with assembler, this kind of code might be available there. OK, where your code will be divided into three parts. That's what we know. So we said that there would be directives. OK, like we know the directives like global, extern, and so on. OK, even these would be the declaratives which would be directing us that this is a byte defined. This is a byte defined. This is reserved double. So whether you are taking this BSS or not into consideration, but maybe like if at all you plan to do that, you can work with this. OK, similarly, this section would be telling us that this would be a data section and so on. So you are going to get this information from the different data structures that we have added. OK, so like you start reading that file from first say line. You got section. Now when you get delimiter like space, you stop there. OK, try to see whether do you have anywhere section defined. So what exactly you will be doing? You will be working with now your this particular screen. OK, like you will work with this now. You got first line. Now you are going to verify like when you reach to section. So you will give that input and then that code will check in one of these what exactly this section is. So it will come to know that it is kind of directive. It is telling me that it is something there which would be related to. So section and along with it, it would be dot data. So it will try to find out do I have dot data available. So if you recall, like let me make an error in the code so that you will understand what exactly I am trying to tell you. So let me modify my code. So in section and data, I am going to add one more space. OK, so this is my code that I have. So I have added a space here. Fine. Now let us save this and let us go back to terminal and let us try to assemble this code. NASM -plf32 array.asm. So it says unknown section attribute data ignored on declaration of section. OK, because section tells you that dot would be accompanied with something. So we know now, like think of this as a transition diagram. So when you reach to section, then you know either it after that dot DATA would be there, BSS would be there, or text section would be there. Correct. So you have three different mechanisms or three different set of states rather, which would be following. So either you would be going to dot data, then dot data knows what exactly will occur later, correct? If we see this code ultimately, correct? So now if I make this correction, okay, and if I add this now error, okay, so let me again do this. So it says instruction expected. Now this may be a confusing stuff rather in terms of, see, the error is given for a line which itself is not containing any instruction. But anyway, our idea of instruction is what? Our idea of instruction is only this, like, okay, my instruction may look like this, which is containing opcode. But this also is kind of instruction given. What exactly you have to do? You have to declare a data variable called msg or identifier called msg. Type of it would be byte and value of it would be this, and then you compute the size appropriately, size of this one, which you can add into your symbol table. Now when it identifies this, so like if I go back and see the particular diagram like this, okay, so I can see that it will read this, it will give the complete after reading the complete line, it got section dot data, it verified it, then again return back, again it will go into next line. So now it got msg here, correct, as per our code. So msg, so it says msg db, it got everything into buffer, it is dividing that, msg is divided, db is divided, enter the size of array 10, 0 is divided by the lexical scan unit, correct? And now what exactly it is having with it is, it will now have three components. So it will first check what exactly this .msg is. So .msg it will try to find, is it opcode? But now we can have an intelligent code, like where whenever a data section is, we will say it will never check with opcode. So then it should go here. But then with that case, it will only check here the declarative aspects. Okay, like DB is there. But what about the symbol? So symbol entry would be added here. So before adding that, it will try to check whether your MSG, what are the MSG variable that you added there in your code, is it part of rather your symbol table or not? Correct. So like let me add the source code also in the comment window. Okay, you can see the comment window where I'm adding this image, which you can see side by side as a code perspective. 1 minute. Pictures, screenshot. Yeah, so you can take help of this source code I'm referring to. Fine. So you please keep this copy, okay, in front of you. I have added that image, okay, of the source code. Now you have this source code available and you are reading it one by one. So you got MSG. So you will check whether this symbol table contains MSG. Now if it is not there, it will add the entry. Now it knows at what location it got added. Then it checks DB and appropriately size computation would be done and would be kept into symbol table. Now again it will go back because it got end of line. It will again go to source file. Is there any entry? So it will start taking that file. So it got fmt2 db array element is %d. It got that file into this. Now again it will check. Okay, it will divide fmt2 db and so on. Everything would be distinguished because of this lexical scan routine. So this is lexical analysis because it is what it is doing. It is creating lexicons. Lexicons is set of components, like there would be identifiers, there would be values, there would be important elements like db, dd. For example, if I talk about C, then integer, float, okay, kind of thing. So that whole thing would be collected and would be given some labeling. fmt2 for it would be probably a label. So okay, label, then it should go to symbol table. db looks to be a declarative one. Okay, let us try to see where exactly the components are added, and then remaining thing would be value. Now when the value is stored, so we already saw that whenever we do talk about enter the size of array, actually E would not be stored there. E would be stored as an ASCII value which is converted to hex. That conversion should be done here as well. Correct. Now all symbols would be added here. So if it will go to FMT2, then FMT1. Now you have symbol table populated. Now it will again go to section.bss. So for a while we will avoid that because I'm assuming that first part that I want you to implement, you are not going to consider BSS at all. Okay, then it comes section.text. Again, it is reading that it got that section.text here through the source file, and now lexicons are collected. It passes that information and verifies. Okay, section.text is available. Yes, next. Now, if that is not available the way that we saw, when I added a space in between dot and data, it throwed me an warning. So that also would be taken care of by this error procedure. That's what it is telling us, that there would be error procedure. Okay, this error procedure will display the errors without generating object file. Now sometimes an object file may be generated. Okay, now for example, what are the code that I wrote there? Okay, if I say for example make an error in my program. Now what happens is when I make an error in the program, and if my say for example object code is generated, then whether all errors would be shown or not. This would be one important thing that I need to address. So suppose now this is my code which was added by us. So let us make an error here. Okay, suppose I am adding this. So let us see whether it is an error or not. We will talk about. So let me try doing this. So it says what? Comma expected after operand 2. What happened was when you go here, when message, it knows what should occur after message. It knows it should be DB, DD, DQ, DT, DW and so on as per the Intel standard. Okay, so it verified yes, DB is available with me. Then it talks about this string. So yes, it is available with me. Then comma, it got it comma. So it says 1, but after 1 space should not be there. So what it could have done, if it could be an intelligent code, it could have skipped all these spaces. But this 1 and 0 at different time may have different meanings. So it cannot directly delete this or trim these in between spaces. We don't know what was the reason the user added those spaces. Correct. So that's why these spaces for these spaces only the error shown was this like comma expected after operand 2, and this was your operand 2. Correct. Message was your instruction for it. This was first operand and this was second operand. So even if I go with this to be first operand because comma is there, correct, then you may say 1, then there is a space, so space is not permitted. Correct. Similarly, if I try to remove this error by adding this, let me make the error here. Okay, for us it may be error. So we are saying it may be. So let us check whether is it displaying error to add ESP comma 4. It will not throw because here in such a case, whenever we are talking about this, it already skipped. Let me show that thing to you. It already skipped these spaces, and that's why it is showing you 04 directly. This ESP comma something gave this C4, which was mod RM, and this add for 83. Okay, so that would be taken care of in text section, but this would not be this cannot be handled when the space is added into data section. Correct. Now what if user keep creating such kind of errors? Then the warnings should be thrown like this. What are the way that we saw? Say for example, comma expected or instruction expected or this kind of stuff. So that is the reason why this error procedure is added over there, which would be returning you the exact error. Okay, with this. Now suppose let us make again another change. Now we know that we added a space here. Okay. Now I purposefully am writing this add ESP comma FMT2. Okay, and FMT2 is a string. So it is providing that address. So was it an error? No. correct? So let me show you where exactly I am making the change. Yeah, so I'm making the change here. I made the change here. So I added what? Add ESP comma FMT2 instead of add ESP comma 4. Okay. So will this be an error? So if I try to translate, it says no error. Correct? It says no error. Then next what? If it is not an error, then let me go to this GCC array dot o dash m32. Now if I execute this code, now I will be getting segmentation fault. So this is runtime error. So that means what? Like if I go back to my screen, rather the screen which I was sharing, I said that there would be error procedure which would be talking about this, but some errors would be generated at the time of like the executable is executed. So they generally we call it as runtime errors. But then you may say this runtime error was not thrown by your assembler. That runtime error was thrown by your loader, correct? Because when it executed the code, now let me see what exactly or what kind of translation was added with that line. What are the line that we added? So let me show this thing to you. Now see this, wherever we added that FMT2, correct? It is assuming that it is an address because this address can be picked from here. 19. But when exactly it starts execution, it doesn't have access to this location. That's why at runtime the segmentation fault is. Now, whenever we see this error, we say there is some logical error that I have found. But actually, it is not a syntactical error. It is not a translation time error, but it was an error generated at runtime. And that error was generated because of my code only. It is not it generated that error because of something else internally. It is not. It is because of the code that I wrote. Fine. Okay, so like there would be similar kind of situation in front of you. Now, if error is not there, then you definitely can move further. Now, in the diagram, it talks about this pass indicator. Now, let us see how exactly you would be doing. So, if I have a source code where now there are two types of assemblers that we would be discussing. One is called as one pass assembler and second one is called as two pass assembler. In one pass assembler, you would be searching your code only once. You are going to scan your code only once, and in a two pass assembler you are going to scan your code twice. So there can be change in this structure. What are the structure that we are seeing? Structural representation of the whole organization of the code can change depending upon the which kind of assembler you are implementing. So this pass indicator may help you on that front. Now if I have one pass assembler, problems in front of me would be what? Now recall we talked about forward jumps. Now, if at all a symbol is to be added into the symbol table, we took that day one case like where a symbol was not found. So we kept it as U. Correct? A label was there, jump LP. So we added that LP entry into symbol table and we said that is it defined? No, undefined. So we kept U. Now when we found that, what exactly we are going to do? We are going to populate or change symbol table entry. But what about the instruction? What is it getting translated? Because when we write jump something like jump to a label, so let me show that code even to you. Okay, 1 minute, please hold. CMP EX comma ECX. So I'm adding that code now for you peoples. So as I can introduce you what exactly I'm talking about. Now suppose my label occurs here and then I have entry. Suppose my code is like this. So see here, what is the challenge in front of us now? We have, suppose we got this instruction, we know now what is to be done. Check whether move is available with the opcode table or not. So I will give you that flowchart as well, like in the book of David Solomon, which I referred for you peoples rather, you can find that opcode, sorry, the flowchart of how exactly this is to be done. But whenever we are getting this like jump LP, this LP entry would be done into symbol table, but we don't have address of LP right now. So it will become U. So can we replace the jump LP? Now let me show you what I am talking about. So let me try to generate an LST for this. If you see here, when we wrote jump LP, it wrote this 6. Now suppose if we don't have entry at all of LP in the symbol table, will we be able to translate this code? Definitely not. Object code cannot be generated. So what happens is in one pass assembler, where it is going to scan your code only one time, only once. So it gets the instruction, translates it, and suddenly it gets this one. So every task could be carried out in one phase only, adding into symbol table and generating the source code, generating the object code. Correct. So this would be done. Like there is no symbol table entry, only verification. Convert this by making use of mod rm byte. So when it is done, you move to next line. Again, do the same thing. Move to next line, do the same thing, and so on. Now, when you reach here, jump LP, you identify that LP is not available in symbol table. Because jump instruction tells you that check for symbol table entry for whatever the entry that you have here. So when it is not found, this instruction would not be translated. Correct? We would not be getting this. So this will go into something called as table of incomplete instruction. Gedit. Okay, so it would be getting table of incomplete instructions. So this is referred as TII. Now why it is so? What are the instruction that we saw here in the code? Which was that line? We are talking about this when we don't have entry of LP available in your symbol table because it is still undefined. It is still undefined and what it should add there. Now let us see. Let me make one change in the code so that you can understand in greater detail. Suppose if I write here extern LP and suppose if I remove this LP. Fine. Now if I now see what the code is. Check once what is the code that I added. I haven't added an entry of LP, but I said that LP entry would be added later. LP would be undefined. Now let us check it. Let us try to translate. Has it given us an error? No. If I try to see what is the say intro1.parse.o. So you can see that LP entry was added, but it is with U undefined. Even if I go with readelf -s, you can see that in LP entry undefined. Correct? So now if I try to see the LST, what is added there? See, it says it doesn't have any information. So square bracket is not there. It added what? A round bracket. That means it is an external reference. It is not available here. So this code actually, if I see the object code, okay. So obj dump -d intro1.parse pipe less. Now you see here what it did. So this was jump and then we said something. So it is showing us this thing. It doesn't have idea about what exactly this is. We don't have because source code is ended. Correct here. Where is E? It says main plus 0E. How many locations that I need to wait? Here it says 7 main plus 07. We don't have that idea at all in the reverse assembly. Okay, or disassembly of the code. When we see the code, because if you see both the things are shown as FC, FF, FF, FC, FF, FF, FF. Okay, but what exactly they are? Do they mean the same thing? If I see, if I recall the earlier case rather, when I had LP defined inside my code. Okay, suppose if I add LP here, I can see that. Let us generate the code first. I can see that for both of them, the code was generated differently, EB06 and EB02. But when I tried seeing that with extern, okay, so let me remove that LP. Now let me do this, and if I talk about this, it adds it like this. Like earlier it was 06 because we said that it would be LP. And that's how your symbol table, what we said, na, like there would be search mechanism which would be helping you to find out what exactly the kind of status of the variable is. So we cannot translate this instruction. So what happened in such a case, this instruction would be kept as it is. Now, if I try to say generate an executable from that object code. Okay, so let us try to generate an object code. So we generated. So let us try to create an executable. Dash M32 intro 1 pass.o. It will throw us an error because it could not find LP entry because your symbol table had U undefined. That's what we saw in this case. This undefined status was not changed at all. As it was not changed, so it was not able to find out what is this LP is for. That's why this error was thrown. Correct? So symbol table, if you're while you complete generate, like while your work is done, and then when you are writing that object code into an object file, at that time if you see either of the symbol with U to be the status and which is not an external variable or extern marked with extern, then in such a case an error should be thrown by you. Now how? Suppose let us do this again. Let me make the change. Emacs. Now I am removing this extern for a while. Now let us see what kind of error is thrown. This error is thrown because it was trying to create this when it was about to write .o. Then it identified there are some entries into symbol table. If I show you the pre-processing thing done, see this is a pre-processing done. There was no error thrown. Dash E generates the pre-processed code. That never generated you an error. That okay, this symbol LP is not found. It only verified is there any macro involved. But when it reaches to your exact translation into an object code, then it throws you an error. Correct? Any question? Please ask if there is any. Yes, please. Yes, any question, please? No? Shall we move further then? So in one pass, you are going to generate this. Now what exactly is to be done? That instruction is to be added here so that you can find out. So line number, suppose in our case, that line number was here. So if line number 1 is this, so let me generate that dash lst. So let me first remove that error. Yeah, so we are going to see this. Okay, suppose it starts from here. It got instruction. Okay, it verified through the lexical analysis page. It searched into opcode table, move was found correctly. It translates that by checking these operands, mod rm would be considered here, and your exact code was generated. Next line would be done. It will be doing same process. Third line also would be doing same process. Okay, now it will reach to fourth line. Now when it identifies that LP is not found, so LP entry would be done into symbol table with status to be U. Okay, status to be U, undefined. So this translation would be pending. So line number one translation, suppose let us say line, let me go here. Line number one translation is done. Suppose A, B, C, D. Suppose this is my translation for line number one. Line number two was this add EX comma EBX. Okay, by the way, I'm writing this as a sample case. So PQ, though it is not in hex, but think of this. Think this, that I am generating some code for it. Okay, or if you want, let me take this one. Okay, suppose line number two also was carried out. Okay, this is I'm trying to generate an object code. So you got line number three now. So line number three is CMP EX EBX. So also suppose I got 09 FD. Okay, now I got next line. Line number 4 is jump LP. So it's a jump. For jump, suppose it found 8, but it doesn't know anything here. So what happens is in table of incomplete instruction, it adds an entry. Line number 4, label reference for symbol table entry number 1. Sorry, 2, because we are already added main there. From our symbol table, we already added this main. Correct. So one symbol is already there. So symbol number 2. So we are talking about symbol number 2. And the name of the symbol is LP. And address is status is undefined. So when you get this ultimately what is to be done? You have to check into symbol table entry. What is the address? So it says 06, for example, first time. So what happens is it adds that 06 here and it deletes the entry from here. Okay, so this TII would be converted when you reach to last line. So suppose this would be kept as it is. Okay, so it doesn't know anything here. So this would be incomplete. So line number 5. So line number 5 we had add EDX comma EX. So suppose we got 01 AB. Okay, now line number 6. What is line number 6? Again we got jump LP. So it would be now kept entry empty. So line number 6. So you got now again symbol entry number 2. So that would be added here. Correct. So line number 6 would be kept blank. Line number 7. So side by side I am writing the object code with one pass assembler. So I got line number 7. Line number 7 is what? Add ECX comma EDX. So I got again say line number 7 01 PQ. Sorry, 47. Okay. Now I got LP. Now LP is line number 8. So instruction is RET. So its code is suppose 08. Sorry, 80. Okay. Now you go above. So you try to find out are there entries into your symbol table of incomplete instructions. So yes. So already what you saw was in your symbol table, this 8 was added for LP in symbol table. I'm talking about 8 is added. So you refer at entry number 2 because first entry was main. Okay, and it was suppose line number 0. So when you reach here, so you got now this 4. So this 4 go here at 4 number. Okay, below and write your code. So you suppose your code is EF for jump and then suppose 08. You added it 08 there. Okay, now you have to resolve that. You have to resolve this. What code is to be written because we know for forward references it is number of bytes that are to be crossed, and in backward jumps or backward references it has to go with 2's complement method. So right now I am assuming that I got this. So here I say suppose I got this. And then each entry, when you complete this, this entry would be deleted from your TII. Then this entry also would be deleted from TII. Then when you reach, you got this translation. This is one pass mechanism. Fine. Yes. So if you see the code, rather the book. Yeah. So this was with respect to one pass assembler. So let me do this. So side by side you have to manage, while here I added line number, you have to manage instruction pointer or line counter. So it says start location counter is 0. Read first line. So is it your end of file? No. Then go to next. Is it label? Yes. Then go to 4. No. Then scan line. Read the line completely. Then when you read the file, whether the symbol is used? No. Then go to 3. Correct. So go through this whole stuff and try to see, like, this would be for symbol table manipulation, and side by side it is trying to assemble the instruction too. That's what assemble line. Every line would be taken into consideration. So go through it. So you can refer even other books like Leland Beck or Dhamdere. Avoid Dhamdere because Dhamdere took from here. So Leland Beck would be the better representation or book rather for understanding this one pass scheme. And so you can see, you can understand that the way that we worked out whether it is defined or undefined. So that is what it is talking about. So there are some labels added even, like when these labels are added, what to do at what point of time, when and how to add or manipulate location pointer. So this was one pass scheme, and in two pass there will be some other difficulties added. So any question with one pass, you are going to make use of mod RM code. Okay, you are going to make use of how to represent, how to catch entry from opcode table by considering the operands. That would be one challenge for you peoples. Fine. So work with them small and then go towards bigger things. Okay. Any question? Yes, please. If you have any questions, you can ask me. Yes, any question? Are you there? Nobody is responding.
Yes, sir.
Yeah. So any question, Devesh?
Yes.
No, sir. All good.
No, sir.
Okay, Ritika? Rutika Borade. Okay, so I am assuming at least you understood what I said. Okay, so now what do you think? What would be challenges in front of you if you at all you have to implement this? So anyway, I would be leaving this part on you, like whether you want to go with one pass or two pass, but I definitely want your inputs. What do you think? What would be challenges in front of you if at all you have to design this one pass assembler? What challenges do you think would be there in front of you? What challenges do you think would be there in front of you if at